Good afternoon, everyone. My name is Chidima, and I'm your host for this session. Our next talk is titled Haleon's LLM Translation to Development Story, and this talk is being delivered by Galina and Guzal. As a form of brief introduction, Galina is a data scientist with a background in applied mathematics and informational technologies, boasting 3 years of experience in leading consumer health companies. Currently, she works as a data scientist at Haleon, where she has been involved in diverse data science projects. Guzal is a data scientist at Haleon. She specializes in developing impactful solutions for business challenges. Her projects include the creation of a multi-market influencer forecasting tool and leading the development of an enterprise-wide translation product leveraging generative AI. She is also dedicated to promoting best coding practices within the data science team. Please join me welcome them.
Thanks, everyone. Yeah, and is my mic
Yes.
working? Yeah, so today we are going to talk about language translation, and I have a question for the audience. Why do you think the translator bring a letter to work? Because sometimes language barriers are higher than they seem. Badumts. Yeah, so that's a small icebreaker joke, as we usually do in Haleon. Yeah, so today we are going to stick to this plan. So first of all, we will talk about who we are, about our company, why we don't use machine translated tools in Haleon, about our project, what we built, and we will stick to the plans that you can see on the slide. So first of all, let's talk about Haleon. That's how it's pronounced. We are a leading consumer company, expert in oral health, pain relief, digestion. So we used to be a part of GSK, GlaxoSmithKline, and we became independent over 2 years already. You might not recognize our name, but chances are that you used our product, probably even today in the morning. So from bright smiles to pain-free days, Haleon is dedicated to your well-being. So our product includes such brands as Sensodyne, Advil, Otrivin, Centrum, and so on. So Haleon operates in over 170 countries worldwide, and this extensive global presence means that we need to translate a vast array of material to efficiently reach and support our diverse customer base. So to manage these translation needs, we can approach this into 2 ways. External translation services, so we can partner with some vendors, some agencies that have a range of language expertise and scalability. We can also have an internal solution, utilize it in-house. And in Haleon, we find this balance between the approaches. So to maintain high quality and consistency in our communication, ensuring that we are effectively connecting with our customers, with stakeholders worldwide. And let's talk about use case a bit more. So one of significant challenges that we face in our translation process is turnaround time. So each translation task can take from 2 to 3 days to complete, and this delay can impact our abilities to address market needs promptly. And translation quality is not also validated sometimes. So in addition to this, brand manager might spend around 8 hours to translate a single piece of artwork, by artwork, I mean like package of toothpaste. And it takes like valuable time from brand managers while they can like do other very important brand management tasks. So that's why we decided to build an in-house solution. And the most popular way to tackle translation problem is to use neural machine translation. So in such a problem, a sentence X in the source language is to be translated into sequence of words into sentence Y in the target language. So what's the logic behind it? So neural machine translation assigns a probability, so you can see the formula here, to potential translation, and then searches like a subset of potential translations for one of the highest probability. So in different methods, they vary from each other because that's they basically have different approaches how they estimate this function that you can see on the bottom of the slide. So in our solution, we were not using classic MT. We're using GenAI translation, and it's important to mention that they're not equal. So when you are talking about classic MT, and that's what's behind DeepL or Google Translate. So classic MT aligns words or phrases between the source and target language, and it uses like dictionary, some statistical methods, while GenAI translation generates just a new sequence of words, a new sentence, and it has multi-headed attention, and it uses encoder, decoder architecture. So if you've been working with LLMs, you should be familiar with this architecture. To sum up, there are three approaches available on the market: expert, machine translation, and GenAI. So all of them, they have their ins and outs. So the accuracy, if you translate, if a human translate, is high, but it's not efficient, and sometimes it's not time and cost efficient. With MT and GenAI, it's time and cost efficient, but you can't like shift the tone, the style, how MT translates, and you can do this with GenAI. So why we're not using Google Translate, for example? First of all, data security. Second of all, customization, so we can tailor to the company needs, like the style of how we want to translate artwork or legal documents, like change the style. And of course, the last but not the least, accuracy. We found out that translating with GenAI is more accurate.
Yeah, so this is what we've built. We built an enterprise-wide capability to translate text, and we tackled all the requirements that were very crucial for us. So we are able to maintain data security because the proprietary data doesn't leave Haleon. We are customizing our translator to match the tone and style because, of course, given the range of products that Haleon has, it has a very specific wording. For example, for packages, you have very set phrases like "keep away from children" that are very, you are not so free to translate them as you will to another language. We also enable the personalized glossary, so the user can save their preferences for future translation. And we are leveraging the user feedback for constant updates for the model. The app is very simple, very slick design. So on the left, you input text very intuitively and click translate, and you get the translation for the selected language. On the right, down there, you can see the two main user feedback features. You can rate the translation from poor to perfect, and you can edit and select a word that you prefer instead of the one that you were given. And this is then saved, and so you need to adjust the translation only once, and it's going to be used by the model as your preference. If we look a little bit deeper into the application and the information flow in there, we get the user query. Then for the user query, we are gathering the relevant prompt. And how we build it is we get the language-specific guidelines. We get the query-relevant Haleon glossary, so we do have our own data set of the correct translations. And then we gather the user glossary if the user, as I mentioned already, has suggested their preferences. Then we are sending it into a call for the model that runs underneath, which is the GPT-4 of Azure that is hosted by Azure. And we get the translated text. Then the user can rate it and write their feedback, which is fed back into the app database. And you might ask, why would we use an existing model? Why didn't we build our own? We have limited resources, of course. This is the main reason. And the main resource that is limited is data. And our company doesn't specialize in translation, so we basically focused on delivering high-performing product by tailoring the model that already exists. We have two main ways of measuring accuracy: the automated metric, Meteor, which is basically the harmonic mean of precision and recall, with recall weighted higher than precision. And we have the native speaker evaluation that is the feature in the app. How does our tool compare to the competitors, which are not really our competitors, but the alternatives? We managed to get higher accuracy compared to both DeepL and Google Translate. Also, the thing that is very important to us, there are certain features that are not available in these two alternatives. For example, some languages and dialects, and the customization per user. So you might wonder by this point, is it just prompt engineering? Yes, and no. So if we look at what actually gives us these very high numbers, very good performance and happy users, we get the language-specific guidelines and the relevant glossaries per query, so for each specific translation. How did we get that? The language-specific guidelines, we were having a bunch of discussions for each language with our internal subject matter experts, so for example, brand managers for Sensodyne, etc., to pinpoint what is it that the model doesn't really get well, what is it for this particular language that the model is failing to capture. Then to get the query-relevant glossary, we need to do a bunch of data pre-processing and add search optimization, because, of course, for the amount of the data, we could not just feed everything into the prompt. Unfortunately, the prompts can stretch only so much. And for users to actually submit their preferences, we needed to build the infrastructure for that, for the app, and gather the user engagement. And by leveraging all of that, we managed to get way better translations, up to 0.36 Meteor improvement compared to the default prompt, which is pretty high. I know maybe it doesn't look impressive, but the Meteor score ranges from 0 to 1. So 1 is the maximum. So this is, you could look at it as 36% improvement. So our app is available to everyone in Haleon. So we have 20,000 or more potential users. We currently have 27 languages, and there are more in development. And the average user score is 4.5 out of 5. And you can see testimonials of our fantastic users right there. And what are the key takeaways for today? We managed to build, and it is possible to build, a successful translation capability using GenAI. The automated feedback mechanism is key to continuous improvement. And the quality and the ease of use ensure the successful adoption. I'm sure if there are data scientists in the room, you know how the adoption of your product is typically maybe even the task harder than to actually build this product. So we focused on user needs, and that's what made our product successful internally. That is all from us today. Please, if you are interested to read, we have a lot of wonderful texts written by our data scientists on our Trusted Data Science blog and Medium. And we'll open for the questions. Thank you very much.
Thank you, Galina and Guzal. Questions, please. Okay.
A quick one. How long did it take you from development phase to the product to the user phase?
Yeah, great question. That's another thing that we're very proud of. It took us 6 months.
Do you mean the whole thing?
From ideation, yes, from the idea of building it to actually rolling it out into production.
Thank you. I don't know if you can hear me anyways. So thank you so much for the presentation. My question was about how well can it translate idioms, so not just words, but like words that together have a different meaning than just one single word.
Yes, great question. Thank you very much. So it doesn't, it translates text, so phrases as well. And most of the idioms that are present in the language, it's capturing very well. And if we have something in particular, we add it into the glossary, and basically it has it in its own updated Haleon knowledge base.
Let me probably add on this. So if you have idiom in English, because GenAI model that we are using, GPT-4, is trained on like a lot of data in English, so it understands English like quite well. So if you translate it into French, so it will get the meaning because it's using multi-headed attention, and yeah, the quality will be good. But I tried in different language. It doesn't pick up in every language, but for English, it's good.
Yeah, thank you for the great presentation. Really liked it. My question is, you said that you are gathering user feedback. So how do you address this feedback? Do you change the prompts, or is it like automated process? So what do you do with the feedback itself?
Yeah, great question. So we are, part of it is the user suggestions. So this feedback is automated. So if they suggest a preferred translation, it's automatically fed back. And as for the textual feedback, we are gathering it and analyzing it after a certain threshold has been reached. So for example, about 500 new textual feedback, and then we are analyzing it manually currently. Thank you.
Hello, can you hear me okay?
Yes. Yeah.
Great. Thanks for a really great presentation, and I'm super impressed that you beat DeepL and Google,
Thank you.
which is amazing.
On Haleon data with asterisk.
Yeah,
we
but, you know, still, I mean, that's who you're building the product for, right? For
Correct.
Haleon users, so that makes sense. Just a quick question. Sorry if I missed this because I joined a little bit late. But in terms of the glossary that you use to retrieve Haleon-specific data and then also user preferences, can you just tell us a little bit more about the structure of that glossary and the retrieval of information from that? And also, with respect to the glossary, I imagine that you don't have perfect translations of every single, word that's kind of typical to Haleon in all the different languages. So how did you deal with that problem?
Yeah, thank you very much. That's a very good question. So the glossaries are basically the parallel data sets. So there are texts in mostly the source language is English, and then the target language. And the way that we are well, basically we had to do a bunch of data pre-processing because I think it was in one other talk, you had to remove a bunch of duplicates and check. We used back translation to check the sanity of this parallel corpora. And then we are using the similarity search to retrieve them. So we are not storing them, of course, in the clean, in the string formats. Those are vector databases that we're doing.
And we
research
use a
over.
dictionary with glossary in the prompt. For example, for some of our products, you say in English, keep away from children, but in the other language, it could be correctly translated, but on the package, it should be like a bit different, like must be like away from children, whatever. So that's the case when we need a glossary, and we just store it, and it's in the prompt for the specific language. And another glossary is like user glossary that you as a user can put if you have some preferences, or if you notice a similar case with the one that I just shared about children.
Awesome. Thank you.
Thank you.
Thank you.
Yeah, thank you for your talk. Have you tried to use some open source fine-tuned model for this task? Because you have quite a specific translation-related task, maybe
Yes.
to work better.
Yes, great question. We did do a bunch of comparisons with the open source models. The thing is, the amount of data, especially per language, is very limited for us. So we either would have to gather open source data sets to fine-tune the model for the translation task better, or we would have to gather a bunch of sets internally, which is unfortunately impossible, especially for the low-resource languages like Albanian, Croatian, etc. You would be surprised how hard it was for us to gather just 30 parallel sentences, not documents, sentences. So yeah, that's why basically we had to disregard this option for our project.
But we also tried Llama. We tried several DBRX, I'm not sure.
MT5,
MT5.
BART, a bunch
Yeah,
of them,
so we tried like most of them. So GPT-4 is like the best thing I've seen, not only for translation project, but for other like chatbot and generative AI related project in our company. So yeah.
Thank you.
Can't take more questions. Sorry about that. But you can meet them outside if you have more
Sure.
questions. We'll be breaking now for coffee, and we'll be back by 3:15. Thank you.
Thank you so much.